In this video, I'm going to show you how to calculate correlations in SPSS. I'll focus on Pearson's R, although the process will be pretty similar for other types of correlation coefficients. So just a quick review on Pearson's R. It describes the relationship between two continuous variables. It ranges between -1 and +1, where -1 means a perfect inverse relationship, 0 indicates no relationship at all, and +1 indicates a perfect direct relationship. Anything between 0 and 1, or 0 and -1, indicates varying strengths of relationship. So let's pretend we're interested in the relationship between IQ and GPA. So first let's get some data in here, which I'm just going to paste in from some numbers I made up earlier. You can pause the video now and enter them in. So as you can probably guess, this first column are IQ scores. They range from about the 80s to around 120. The second column indicates different GPA scores, which have the potential to range between 0, which means you're failing everything, and 4.0 means you're acing everything. And it looks like in this data set the lowest score is about 0.8 and the highest GPA is about 3.7. So before we do anything else, let's make this easy on ourselves and rename these variables. So I'm going to go over to variable view and just rename this first one IQ scores and the second one GPA. And I think all the other default settings can stay the same. So these data are set up in a very specific way. The order of the scores really doesn't matter as long as each pair stays together. So for example, this first person has an IQ of 112 and a GPA of 3.3. And this pair of scores can go anywhere. It can go at the top, it can go somewhere towards the bottom, or it can go even in the middle. The point is, they need to stay together. And indeed, these scores I have in here aren't ordered in any logical manner. The only thing that's important is that each IQ score stays with each GPA, because it reflects scores obtained from one individual person. This is one person's IQ and GPA, this is another person's IQ and GPA, it's a third person's IQ and GPA. If we change the order of one set of scores but leave the others the same, our correlation coefficient won't reflect reality, because there'll be mismatching scores from different people. So just remember that data from each person must be paired together. Also, you can see there are 15 pairs of scores. We don't talk about there being 30 different data points, because when we're doing correlations, it's all about how many different pairs of scores you have. So now that we have the data in here, it'll be relatively easy just to run the correlation. All we do is we go up to Analyze, and under the Correlate option, there are different types of correlations we can calculate, but Pearson's R is a type of bivariate. So we go there, and once we're there, we see this window that we've dealt with before. All the variables we have are on the left, and everything we want to analyze, we move over to the right. So in this case, we need to move over at least two variables. If I move over just one, it won't let me run the analysis. OK is not available, because if we only had one variable, what would we compare it against? We need to have at least two things. Now let's see. We have some different options here too. There are different types of correlation coefficients we can calculate. Pearson's R is one of the most widely used ones, so it's already checked right here. And it's also the most appropriate for these data. There are also ones like Kendall's tau or Spearman's rho. We could use those for different types of data. For now, let's just stick with Pearson's. And below, SPSS also wants to know if we're going to run a two-tailed or a one-tailed significance test, and whether to flag significant correlations. I haven't talked about significance tests very much yet, but these options they deal with detecting whether our correlation coefficients are significantly different from 0. In other words, would we expect to see similar results in the real world? And I'll talk about that more in just a minute. For now, you can just leave these options the way they are. So once you're ready, just click OK, and your output window will pop up. Now what it's showing us is a correlation matrix. That's this box right here. This shows the correlation coefficient of every combination of variables. So we have these two rows, one for IQ, one for GPA, and we have two columns, one for IQ, one for GPA. So where each row and column meet, we see the correlation coefficient between these two variables. We can also see the correlation coefficient is the first thing. Then we see the significance level, or p-value, and then the n, which is the number of pairs of scores that each correlation coefficient is based on. And remember from earlier, we had 15 pairs of scores. So in this first square in this matrix, we see the correlation coefficient between IQ and itself. No big surprise, it's 1. It's a perfect correlation. We see another perfect correlation down here in the lower right, which is the correlation between GPA and itself. You'll see these 1s in every correlation matrix you run, because like I said earlier, SPSS will compare every combination of variables, including each variable and itself. So just be aware that all the comparisons will be the same on both sides of this diagonal of 1s. The comparison that we're probably most interested in is the correlation between IQ and GPA. And notice down here, it's the same thing as the correlation between GPA and IQ. It doesn't matter which one you do against which other. The order doesn't matter. So first it's showing us the correlation is very high. It's 0.986, or almost 1. Below that we also have the significance level, or p-value, which is very small. It's definitely less than 0.05 or 0.01, which are typical cutoffs. I'll explain p-values more in a later video, but for now just know that anything smaller than 0.05 means the correlation is significant, so we'd probably see it in the real world. And this correlation is so small that we can't even see it with 3 decimal places. It's probably something like 0.000001. And in this case, the correlation has been flagged with 2 asterisks, which means its significance to the level of less than 0.01, which is what says that down here. And one last thing I want to mention is that we can compare more than 2 variables in our matrix. We can actually do a lot more. We just need to toss in more variables in the mix. So getting back to the spreadsheet, I've magically included some data on people's shoe sizes. So this first person with an IQ of 112 and a GPA of 3.3 also happens to have a shoe size of 8, and so forth for each subject. So what we can do is, if we go back to Analyze, and under Correlate, bivariate, we can toss in these data on shoe sizes into the mix, into our correlation matrix. So what we get when we hit OK is, right below, we get an even bigger correlation matrix, this one with 3 rows and 3 columns. So what it's telling us is that the correlation between shoe size and IQ is 0.04. The correlation between shoe size and GPA is 0.06. In other words, they're both very, very small. In other words, there's no relationship between shoe size and these other things. And just for the record, too, you can also see these same coefficients up here. Between IQ and shoe size, there's the correlation coefficient. Between GPA and shoe size, there's the correlation coefficient right there. So those are the basics of correlations in SPSS. Just remember that you can make your correlation matrix as big as you want, but they're easier to read if you keep them small. So try and limit your comparisons of things that you think would be theoretically interesting. Also, don't confuse correlation coefficients with p-values, or the significance level. Remember that you want the correlation coefficient to be big, close to 1, and you want the p-value to be small, hopefully less than 0.05.